All right, ladies, welcome back to science class. Today we're going to talk about squashing and stretching, 1.2 in our physics book. So we're going to describe how forces deform objects, and we're going to use Hooke's law. All right, first we're going to talk about changing shape. You see, forces actually do things called deforming. When a force deforms, it can do two things. Number one, it can stretch something. So we can see the ball being stretched, or we can see this person's face being stretched on the opposite side. It can also compress something. We talked a little bit about gases being able to be compressed. But we do know if we had a piece of clay or a ball, we can actually compress and squash that ball. And in order to do that, we need to apply a force. You see, when this happens, either we stretch or compress something, the object's shape has changed. One of the things that is a little bit interesting for people is that when you stand on the floor is actually pushing you up. You see, there's a force that's pulling you down, and there's a force that's pushing up from the floor, just like this. Here we have gravity pushing down and the ground's reaction force pushing up. So this is what happens. First, your weight is going to push all the little floor particles together in a very, very small amount. The bonds are going to be compressed, and they're going to push back to support you. So let's take a look at what that looks like. Here you can see this is where the foot is actually touching the ground, and the particles inside the floor are actually being squashed together, a very, very small amount. This is what happens every time you take a step, every time you put something on a solid object. These things are compressed. So we know that solid materials are compressed a very small amount, and that support force that they're pushing back, like the force that the floor is pushing back for you on the chair, is called a reaction force. Here we can see a reaction force of a skateboarder as he's pushing down on the ground. The reaction force of the ground pushing back is actually helping him to move his skateboard forward. All right, so next we're going to talk a little bit about stretching. So when we stretch something, we can use a spring, a bungee cord, or even things like elevators have long cables. Those steel cables in an elevator actually stretch when you pull on them. The amount of stretch is called the extension. So if we pull it a really long way, we have a long extension. If you pull a rubber band a short way, you have a short extension. The force that pulls something that is stretched is called the tension. Okay? How much tension there is how much force there is on that object. So let's talk a little bit about forces and tension and things like that. So springs, we know, have special force rules. In fact, springs are one of the best ways to measure forces. If you remember before, we talked about spring balances or Newton meters. They have springs in them for a very special reason. One of the great properties about using a spring is if you double the force on a spring, the extension will double also. So we can see that we have a spring over here, and if we double the amount, we have twice the amount of extension. This is called Hooke's law, and Hooke's law has a linear graph, which means the graph is actually just a line. You can see on the bottom, this is a graph of Hooke's law. If you put 1 Newton of force, we got a 2 centimeter extension. If we put 2 newtons of force, we have 4 centimeters of extension. And if we double the 2 again, we should have a double. So let's double 2 to 4. If we have 4 newtons of force, we have 8 centimeters of extension. So when you double the force, you double the extension. That is Hooke's law, and it's very important that you learn it. I put it in red so that you know what it means. Okay, last we're going to talk about the elastic limit. You see, springs are, of course, able to be stretched, but if you stretch it too far, then it will actually break the spring, and the spring won't be able to extend as well again. So springs do have limits. So the elastic limit is how far you can stretch a spring before it returns to its original shape. Okay, and that's kind of a limit to whether the spring is going to break or not. All right, so at the end of this video, you should know how to describe how forces deform objects, and you should know what Hooke's law is and how to use it. If not, rewatch the video. All right, thanks for watching. See you next time.